Welcome to a new episode of Drops of Science, the multilingual scientific podcast that selects for you the latest news in natural sciences. Let's begin today's episode by talking about exceptional dentitions, in particular those of the Komodo dragon. These animals are known not only for being the largest living reptiles in the world, but also for their razor-sharp teeth and their ability to eat any type of meat, capable of tearing and ripping apart everything from reptiles to horses and water buffaloes. The distinctive teeth of Komodo dragons are not conical, but rather zyphodont, meaning compressed teeth with serrated edges composed of dentin cord serrations called denticles, much like a stick knife covered by a thin layer of hard enamel. Currently, they are the only animals on Earth with these teeth, which are believed to have also been possessed by some dinosaurs, including Tyrannosaurus rex. These teeth, however, hide much more. Thanks to a recent study led by Dr. LeBlanc and collaborators from King's College in London, it was discovered that Komodo dragon teeth have an extremely peculiar composition. The researchers, through a combination of advanced chemical and structural imaging, observed that Komodo dragons possessed orange pigment in the tips and serrations of their teeth. Both erupted teeth, those that have emerged from the gums, and unerupted teeth were equally pigmented, implying that the pigmentation didn't come from their diet. Further analysis revealed that the orange coloration was due to layers enriched with iron oxide. The fact that it is concentrated in specific areas suggests that the presence of this element likely plays a crucial role in supporting the serrated teeth. Building on this sensational discovery, the researchers compared these with other reptiles and found that iron is present in other species, but not in this specialized and localized form. Rather, it is more dispersed, and therefore harder to detect even through simple observations of pigmentation. Furthermore, the scientists hypothesized that other extinct zyphodonts might also have had iron-rich serrations in their teeth, but diagenetic processes, the physical and chemical changes occurring in sediments that lead to decomposition and potential fossil formation, could obscure any specific iron signals within the enamel. Currently, the instrumentation required to continue this line of research is lacking. The results of this study are particularly intriguing because they suggest that the adaptation of serrated teeth is not limited solely to structural reinforcements, but also includes chemical reinforcements. These chemical reinforcements, in the form of iron oxide, could have played a crucial role in keeping the teeth sharp and functional for longer periods, reducing mechanical wear during the chewing of tough prey. This discovery opens up new avenues of research, as better understanding these adaptations could provide valuable insights into the evolution of predation mechanisms in reptiles. Let's now talk about one of the most precious gems in the world, sapphires, a variety of corundum, a mineral composed of aluminum oxide. Pure corundum is colorless, but the presence of trace elements such as iron, titanium, and chromium can confer, for example, the typical blue color of sapphire. These are often found in association with silicon-poor volcanic rocks. However, their exact origin and formation often remain a mystery. A team of geologists from the University of Heidelberg in Germany conducted an in-depth study of sapphires found in the volcanic region of the Eifel to solve this enigma. This research focused on determining the geochemical origins of sapphire and their link to local volcanism. The Eifel, an active volcanic system for about 700,000 years, is known for its eruptions of sodium and potassium-rich but silica-poor magmas, an environment typically associated with the formation of sapphires. The team examined more than 200 grains of sapphire from the Eifel, obtained from volcanic deposits and river sediments. The analysis included age determination using the uranium lead method on mineral inclusions in the sapphire, which also allows the identification of the isotopic composition of oxygen. The different relative abundances of the light isotope O16 and the heavy isotope O18 provide information on the origin of the crystals like a fingerprint. The data obtained provided crucial information about the environmental and geochemical conditions under which the sapphires formed. The analysis supported two main hypotheses for the formation of corundum, the crystalline form of aluminum oxide. First, magmatic origin. Corundum can form from highly fractionated silicate carbonate melts derived from earth mantle. These melts can differentiate in the upper mantle or lower crust, potentially separating a CO2-rich melt. In this scenario, corundum precipitates directly from the magma during the cooling and crystallization process. Second, metamorphic origin. Corundum can also form through metamorphic processes where pre-existing crustal rocks such as gneiss, skarn, marble, or pegmatitic intrusives are heated and transformed due to contact with ascending magmas that heat and metamorphose the surrounding rocks. The oxygen isotopic analysis revealed different geochemical signatures for the sapphires, indicating multiple formation pathways. Type 1 magmatic. Sapphires with isotope O18 values between 4 and 6% associated with differentiated melts derived from the mantle. Type 2 metamorphic. Sapphires with isotope O18 values superior than 10% associated with poorly metamorphic crustal parent rocks such as mica schist. Type 3 hybrid. Sapphires with intermediate isotope O18 values between 6 and 10%, requiring varying degrees of mantle crust hybridization. This oxygen isotopic zoning observed in the sapphire crystals indicates a complex formation history. The cores of the sapphire with high O18 values indicate a metamorphic origin, while the rims with lower O18 values suggest magmatic influence. These variations indicate that the crystals initially formed under metamorphic conditions and subsequently experienced magmatic influences, likely due to the mixing of different types of magma. The volcanic context of the Eifel with its eruptions of alkaline magmas offers an ideal environment for sapphire formation. Both magmatic and metamorphic processes plays a crucial role in the crystallization of the sapphire. The zoning of oxygen isotopes and the different geochemical signatures indicate that the sapphire crystals have an intricate formation history. These results not only clarify the origin of the Eifel sapphires, but also provide a model for understanding the genesis of sapphires in other intracontinental magmatic contexts. We now move to Africa to discuss how algae are valuable witnesses to past habitats. Doctors Fitchett and Mackay from the University of the Witwatersrand, South Africa, and University College of London have sought to reconstruct the ancient landscape in a bowl-shaped depression at the summit of Mafadi, which stands at 34 meters above sea level, along the Great Escarpment in the eastern highlands of Lesotho. The eastern highlands of Lesotho are often referred to as the water tower of the region because they receive some of the highest amount of rainfall in southern Africa, providing water to South Africa and electricity to Lesotho through the Lesotho Highland Water Project. Despite this abundance of water, there is only one confirmed natural lake in the area, alongside small seasonal ponds on the rocky ground. But has it always been this way? The area is known for small white patches in the landscape, which are diatomites, consolidated sediments composed mainly of biogenic silica from diatoms, small algae that can have marine or freshwater origins. Diatomites formed in freshwater environments can provide valuable evidence of paleolakes and their characteristics. The researchers, aware of the presence of diatomites in the area, decided to better understand the paleoenvironment of this region. To do so, they use a suite of techniques. The mere presence of diatomites is not considered sufficient to confirm the presence of a lake, so they extracted a sediment core, identified the diatom species present in the diatomite, and determined the potential habitat of this species. The results were compared with published diatom sequences from contemporary wetlands, and chemical analysis of the sediment were also conducted, as well as analysis of the precipitation and site topography in relation to the only known contemporary lake in Lesotho. Through this complex methodology, the scientists discovered that the diatomite record spans a full 4,500 years. The dominant species found suggests persistent shallow water conditions, common in high-altitude lakes in Africa. The diatom flora indicates that the diatomite formed in a shallow lacustrine ecosystem, not from the continuous presence of spring water. The Mafadi Paleolake was likely frozen for much of the year, but open during the summer, allowing nutrient recycling and the growth of a small community of planktonic diatoms. The site's topography, with a bowl-shaped depression and a descending valley draining wetland, is conducive to lake formation, and the average rainfall is much higher compared to the only existing lake. All this confirms that in the past there was indeed a lake on Mafadi. But what happened to it? It is difficult to give a direct explanation, but the researchers suggest that the lake disappeared in recent times, around 150 years ago, due to various factors, including post-industrial global warming of about 1.1 centigrade and increased livestock exploitation. In fact, livestock may have had a direct impact on the availability of surface water through water consumption, and secondary impacts caused by grazing and changes in vegetation growth. Trampling of the soil and loss of vegetation can cause soil erosion, and in the high altitude areas of the eastern highlands of Lesotho, the topsoil layer is already very thin. The disappearance of a mountain lake in the past century raises significant concerns for the hydrological security of Lesotho, considering the importance of water as an export resource. This also highlights the urgent need to improve water management in this region, in the face of increasing frequency of drought events. Let's talk now about wildlife tourism, which is the practice of observing wild animals in their natural habitats. This phenomenon has been increasing over the past few decades, with its pros and cons. On the one hand, wildlife tourism can have a negative impact on the species it targets, affecting their diet, reproductive success, foraging intensity, hormone levels, habituation to people, and changes in social systems. On the other hand, if managed properly, it is an important tool for raising conservation awareness for all species and for public education. Studying the impact these activities have on animals is essential for developing appropriate regulations for a better management. Dr. Niella and his collaborators have studied tourism related to the great white shark, Carcharodon carcharias, as cage diving is an extremely popular activity that draws attention to a species important for conservation but also potentially dangerous to people. This practice has raised concerns that the use of food attractants may cause great white sharks to associate boats with food sources, increasing interactions with people and potentially the risk of attacks. They collected data using fine-scale positioning from passive acoustic telemetry to track the movements of great white sharks over a period of 5 years, checking if there was a relationship between interactions with people and the potential risk of attacks, considering that olfactory and visual attractants are used to bring sharks close to the cages. According to the scientists, the sharks should have associated the presence of cages with the baits and understood that the presence of boats implied the presence of food, approaching them frequently. Surprisingly, the results showed exactly the opposite. The sharks did not become more present or stationary near the cage, diving boats over time. In fact, they showed habituation to the food attractants and reduced the time spent near the boats within 10 days of their presence at the tourist site. Past studies have demonstrated that sharks have a variety of learning capabilities, including quickly associating various sensory cues with food and engaging in social learning. However, in this study, no evidence supported the hypothesis that great white sharks associated both with food sources. This lack of conditioning was attributed to regulations that prohibit cage diving operators from directly feeding the sharks and limit the use of food attractants. The regulations limit the amount and frequency of food rewards available to sharks, thus affecting their ability to learn the association between food and boats. Even when sharks manage to consume the bait, this happens rarely and not systematically, further reducing the likelihood of conditioning. Great white sharks therefore spend less time near the boats because their response to olfactory stimuli decreases when they do not obtain the food they perceive. Sustainable wildlife tourism requires that interactions with animals are managed in a way that minimizes negative impacts. Feeding wildlife to enhance visitor experiences can affect the natural behavior of animals, but in the case of the great white sharks, effective regulations have reduced such impact. The study's results reassure the public that these activities do not increase the risk of shark attacks, showing that sharks quickly habituate to tourist boats without developing dangerous associations with people. The latest news concerns a unique defense strategy of bees. These animals, classified as eusocial, live in colonies with numerous eggs, larvae and adults, making them highly attractive to predators and parasites. For this reason, bees have developed remarkable defense methods. For example, honeybees use shimmering waves by lifting their abdomens in succession, causing the entire colony to dazzle the enemy. Another method is defensive balling. When a hornet enters the nest, the bees form a hot defensive ball, trapping the hornet inside and heating it up to 46 degrees Celsius with their body heat. Another method is constant grooming that prevents the arrival of parasites. Another highly effective method against ants, which are major consumers of honey, brood, and worker bees, is ventilation. Bees use the wind pressures created by their wings to keep ants away from the hive entrance. But that's not all. A recent study has filmed Japanese honeybee colonies adopting a more aggressive approach. Through hours of video recording, a team of Japanese researchers has detailed how bees strike ants through direct contact with their wings. The worker bees tilt their bodies toward the ants and then beat their wings violently to slap the intruder, a behavior completely different from simple ventilation. This behavior was observed with various ant species, demonstrating that it is the most common behavior when ants are very close. However, Western honeybees show distinct responses to different beetle species, so further observation of Japanese honeybees are needed to understand if their response might be species-specific. In this study, while wing beating had a success rate of about 1 in 2 or 3 attempts in repelling Japanese queenless ants and Japanese pavement ants, the success rate against Japanese wood ants was relatively low, suggesting that the behavior might not be effective against all ant species. Given that Japanese wood ants are larger and move more quickly than the other species examined, it may have been more difficult to repel them successfully. The researchers hypothesize that this behavior evolved as a low-energy defense, while ventilation is more suited against predatory species with a strong bite. In Japan, where predatory ants like the Asian weaver ant are absent and the threat of direct predation from ants is low, non-contact defensive behavior may not always be optimal. Ants with a low threat of direct predation can be more efficiently eliminated through direct contact rather than wind pressure generation. It is crucial to understand the different defensive strategies of animals, particularly bees, considering the rapid spread of predatory species with which they have not evolved, increasing the risk of predation. If Japanese honeybees respond to these non-native predators with wing slapping, they might be at a higher risk of mortality compared to other honeybees that exhibit non-contact defensive responses. This concludes today's episode of Drops of Science. Thanks for staying with us. See you soon, and good science!